Without using your calculator, find the asymptotes and axis intercepts of the following functions and hence sketch the graphs. So let's start with the vertical asymptote. The vertical asymptote is when the denominator is equal to 0. So here we get x is equal to 5/2. The horizontal asymptote is what happens as x tends to infinity. So as x tends to infinity, in this case, y tends to, well, when x gets really big, 3x plus 2 tends to just 3x, and 5 minus 2x tends to minus 2x, which is equal to minus 3/2. So our y-intercept is going to be minus 3/2. Our y-intercept is when x is equal to 0. So y equals 2/5, or 0, 2/5. And our roots are when y is equal to 0. So 0 is equal to this fraction, but that just means that 0 is equal to the numerator because the denominator can never be 0. So solving this, we get x is equal to minus 2/3. So our root is at minus 2/3, 0. Knowing all that, let's sketch the graph. Put in my axes first. I'm going to put in my asymptotes. X is 5/2. That's going to come down something like this. Y is minus 3/2, so that's going to come through something like this. And then it's going to go through 2 points. It's going to go through 0, 2/5, which is, let's say, about there. And it's going to go through minus 2/3, 0. So that's about that point there, which means we've got one bit of our graph coming up like this towards these asymptotes. And because this is a rational function, there must be another bit going down on that side, diagonally opposite. Labeling the points, this point here is going to be 2/5, we said. This point here is minus 2/3. This is x equals 5/2. And this is y equals minus 3/2. Let's look at the second one. For this one, we'll do the same 4 things. First of all, the vertical asymptote. Vertical asymptotes are when the denominator is equal to 0. But this is a quadratic, so we're going to factorize this to get x plus 5, x minus 2 equals 0. So we've got 2 vertical asymptotes at x equals minus 5 and x equals 2. Horizontal asymptotes are as x tends to infinity. In this case, y is going to tend to, well, the top's going to tend to minus x. The bottom's going to tend to x squared, because when x is massive, it's only the highest power of x that really matters. And this tends to 0, because it's going to tend to 1/x. As x gets huge, that's 0. So our horizontal asymptote is y equals 0. Our y-intercept is when x is equal to 0. So we get 4 over minus 10. We've got 0 and minus 2/5. And our roots are when y is equal to 0. So 0 is equal to 4 minus x, which means x is equal to 4. So it's 4, 0. To sketch this, let's draw in our axes. Our vertical asymptotes are x equals minus 5 and x equals 2. Our horizontal asymptote is the x-axis at y equals 0. So this is at x equals 2, x equals minus 5. And then we know the y-intercept is at minus 2/5, so the y-intercept is about here. And the root, the single root, is at 4. So given that this is 2, that route's going to be about here. So what's going to happen between here in these parts? Well, this bit in here, we know it's got to be negative at some point, at this point, and there's no root, so it's got to always be negative, which means it's going to come up from this asymptote. It's going to come up somewhere like this, and it's going to come down like this, because it never crosses this axis. It's got to approach these two asymptotes, and it never crosses that axis. It's got to go through that point. Okay? Now, these ones are a little bit less obvious what's going on, and the best thing to do would be to think about, let's choose some numbers. So at minus 10, for example, what would this be? At minus 10, 4 minus minus 10 is positive, and then we'd get minus 10 squared is 100, minus 30 minus 10, that's going to be positive. So positive over positive is positive. So this bit here is positive, which means this whole bit has got to be positive because there's no root, so it's going to have to do something like that, approaching the asymptote that is the x-axis. On this side, though, we've got a root. So let's think about either side of the root. Let's think about at 3. At 3, we get 4 minus 3 is 1, so that's positive. And then 9 plus 9 minus 10, so that's positive. So it's positive between the asymptote and the root. And then after the root, let's choose, let's say, 5. 4 minus 5 is minus 1, so that's negative. 25 plus 15 minus 10 is positive. So we've got negative over positive. So after the root, it's negative. So it's got to be up here, and then it's going to come down. But it's also got to approach this asymptote. So what's going to happen here is it's going to come down, and then it's going to come down, and then it's going to bend back up towards the asymptote and go off like that. We don't know how far that's going to come down, but it's going to come down and bend back up and then approach that asymptote. So that's how we can sketch the graphs of rational functions, either linear over linear or linear over quadratic. Now in this skill, we're going to look at what happens when we have a quadratic over a linear and how we can sketch those graphs.